Assalamualaikum and hi everyone, we are from group 5. Today we are going to present our video about the similarities of IV graph between the graphical method and the simulation method. Before that, I would like to introduce our team members first. AIMAN SYAZWAN bin Azman, SYAFIQ AIMAN bin ROHADI, HIDAYYAH binti SULONG and UMIYRAH binti SAPIE. So, I will proceed to simulation method first. Question 1 asks us to find the IV characteristic graph by using multi-sim apps, and we need to determine our own voltage source. For our group, we choose 2 volt for voltage source. I arrange the circuit in series connection since like the question, and we use IV analyzer to obtain the IV characteristic graph. After completing the circuit, we need to run the simulation, and this is the graph that we got from the IV analyzer.
Assalamualaikum, my name is HIDAYYAH. So here I want to explain how I make every characteristic of diode. My part is to construct a graphical by using manual calculation, which I am using this Shockley equation to find ID value. Then I make a table characteristic because it's easy to plot our graph later. So from the table characteristic, we can plot our ID and VD value. So here the graph that I get from my manual calculation previous.
Hi, my name is AIMAN SYAZWAN. I continue the presentation about simulation method in question 2. Okay, first, we need to construct the circuit in multi-sim to make the IV characteristic graph. This circuit and graph shown the IV characteristic for the simulation method question 2. To create the table IV characteristics, I perform the Shockley's equation to define the ID by changing the value of the IV analyzer in multi-sim. And also, we can make the simplified circuit like the graphical method to find the load line for the circuit. This circuit is completely done simplified and I'm using the ammeter to get the value of ID.
Hi, my name is UMIYRAH and today I'm going to explain how to obtain the value of IDQ and VDQ. So first we have to simplify the circuit by using the Thevenin method until we get this simplified circuit. By using this simplified circuit we can find the value of R Thevenin and V Thevenin until we get the Thevenin circuit, which will be used to find the value of ID and VD. So by using the KVL method, we can obtain this equation, and with the condition of VD is equals to 0, we can obtain the value of ID, which is equals to 18.16 milliampere, and then in the condition of ID is equals to 0, we can find the value of VD, which is equals to 3.3 volts. By using the value of ID and VD, we can plot the load line on the IV characteristic obtained, and finally we will get the value of IDQ and VDQ.
Hi, as you can see from this slide presentation, I continue the explanation about dissimilarity for graphical and simulation method. For the first, the value of ID in graphical method is unacceptable and make us difficult to plot our graph. We can see the breakdown of diode, but when the diode in fault bias, the value is very high than in simulation. In the simulation, we can define the ID which change the value in voltage range. We use IV analyzer to complete our table and graph to make the IV characteristics of diode. After we change the value VD in voltage range, we can get the accurate value of ID for the IV characteristics. For the question 2, the dissimilarity for the graphical method is same like question 1 to find the IV characteristics, but the voltage source is 20 volt. The value of using graphical method is unacceptable between using the simulation method. For the simulation, we can get the same value of ID and VD, but to make the load line is very difficult. This is the simplified circuit by using the Thevenin theorem, which is using simulation method. We can find the ID and VD by using the ammeter and voltmeter. Okay, next, I want to present our content of report. First, is the chapter 1 is introduction. 1.1 is problem background, and problem statement. 1.3 is aim and objective. For the chapter 2 is methodologies. For the chapter 3, we discuss about our result and discussion. for the question 1, graphical method, simulation method, and the similarities from the graphical method and simulation method. And the question 2 of the graphical method, simulation method, and lastly the dissimilarities for the graphical method and simulation method. For the chapter 4, we discuss about the diode application in biomedical engineering. And lastly, for the last chapter is chapter 5, is the conclusion. First, we discuss about our self-reflection, and lastly for the conclusion.